Hello class, today we are continuing in our unit about matter and its interactions. Today's lesson is going to be about the law of conservation of matter. By now you should have opened up this worksheet in your Google Classroom. It does look long, but I promise you it will go quickly. Be sure to fill this out as you are watching the video, or you can go back and review the slides. I did give you a copy of the slides as well if you need to go back to look at an individual slide. For the first activity that we get to, you will be filling in this chart. So I'm going to ask you to fill in the chart in grams of the weight of the popcorn in the bag before microwaving. This is where I'm asking you to put that. You could do this demonstration, the first one at home, if you have the materials. If you don't have the materials, though, they are not needed. You'll just want to watch the demonstration that I do here on the video, and you'll be able to answer any of the questions from there. I will do my best to record the demonstration part. Just bear with me. My recording tools might not be quite up to par. But let's go ahead and get started. So I'm on the Google Slides that I sent you, and I'm going to do a present format so we can talk about those. So again, we are looking at matter and interaction, specifically today the law of conservation of matter. A little bit of review first, though. What is matter? Matter was anything that has mass and takes up space. So in this picture, you can see really anything that's in that picture can be classified as matter. It has mass, takes up space. So the elephant, the car, the people driving the car, any of the plants and the ground, everything that you see is matter. Something that you can't see that we've also learned about is that air is also made of matter. Air has mass and it takes up space. And we found that out through a couple of the activities that we did prior. Okay, along with matter, we learned about an atom. An atom is your basic unit of matter. And we know that that consists of a central nucleus surrounded by a cloud of negatively charged electrons. And if we remember back from our lesson, we might remember that between the nucleus and those electrons really is a lot of empty space. But we can look real quick at a video of the atoms in steel, particularly. And this is a video that's going to zoom way in on the steel atom. So it's kind of interesting as they do their zooming. And you'll see in the bottom right corner, it'll tell you how many times they've zoomed in for that.
This is just a broken-toothed gear. It's made of conventional steel, composed mainly of iron and a small amount of carbon. This small quantity of carbon is enough to protect the gear from corrosion, but not enough to make it indestructible over time. To increase steel's resistance, other elements are added: nickel, manganese, chrome. This way, hundreds of different types of steel are made. As we move closer, this fracture allows us to discover the structure of the alloy. A rugged landscape materializes. Here and there, a scattering of white specks. They're tiny particles of dust that have settled on the surface. Each of these petal-shaped forms is a particle of steel called dendrite. An alloy of iron and carbon, dendrite is found in all solid matter that crystallizes in cooling. It's found in steel, aluminium, and even in snowflakes. When cooled rapidly, steel increases in strength, a process known as tempering. Between the particles, a cavity is outlined. We'll continue our journey through this hole, which is probably due to the aging of the metal. In the background, a grain of perlite emerges from the shadows. It's easily recognized by its characteristic sliced structure. The thick black diagonal cutting through the perlite contains a little more carbon than the lighter areas around it. So do the other thin lines. It's this extra carbon that gives the darker color. The fuzzy black and white flecks are faults in the structure brought into focus by the microscope. At maximum enlargement, a series of tiny regular spots appear. Here, at last, is the atomic structure of steel. Atoms of iron and carbon regularly stacked in all directions.
Okay, so they were able to magnify it several thousand times to get down to that single atom. And as you recall from our class discussion, an atom is too small really to be seen with our eyes. So magnifying like that would be the only real way to see those. Okay, so we do have our first activity. Our first activity is called snack break because this here is going to end up being a type of snack. So what do you think that snack is? If you guessed popcorn, you are correct. And this is a close-up image of what it looks like for that popcorn to be popping. We are going to be trying that ourselves by weighing a bag of microwave popcorn. And of course, I'll remove it from the plastic before microwaving, so we don't have an issue with that. I would like you to predict the weight that you think the popcorn is going to be in its bag after microwaving. So without us opening the bag out, do you think the bag of popcorn is going to weigh the same as it did when we first weighed it? Do you think it's going to increase in weight, meaning it's going to be heavier? Or do you think the weight's going to be exactly the same as when we put it in the microwave? So on your worksheet, remember I said on this spot on your worksheet, you'll record this. I want you to record what I'm going to tell you as far as the weight in grams of popcorn. And I'll be showing you that on my scale in just a minute. And then I want you to go ahead and make your prediction of what the total weight after microwaving it will be. So will it be a little more, a little less? Do you think it will be the same? So let's go ahead and check that out. Okay, you can see my digital scale here. Let me see if I can expand this just a bit for you. Okay, and I just need to turn that on. I do have my popcorn ready to go. Zoom out a little bit, maybe you can see it. See what I'm doing a little better. Okay, here's my popcorn. Let's go ahead and place that on the scale. And it looks like you will want to record, make sure it's centered. Yep, let's record 93 grams for what it was before. Okay, then our next step is to go ahead and put that in the microwave. On my bag, it said I should do 2 minutes, 30 seconds. Let's see if you can get a view of the microwave. There we go. And just know the second part of our, we will end up having 2 parts to our video because I do have a time limit as far as how much I can record with one. All right, so popping it in, we'll do 2 minutes, 30 seconds. And you should at least be able to hear it as it's popping. I'm hoping that you can kind of see it as well. See if I can get you a better angle on it. There we go. If you look closely, you can see that popcorn bag going around on the turntable. Oh, I'm starting to hear the butter in there sizzle just a little bit. 40 seconds left for popping. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, now remember we wanted to see if it changed in its mass at all. So I'm going to take that out. It is going to be quite hot, so if you're getting yours out, you will also want to be careful of that. As I take it out, you might be able to see I've got some steam coming off from there. I'm not sure if that picks up in the camera or not. It's quite a bit of steam coming out. And I can kind of feel inside, and it does feel like a slight bit of moisture in here. Let's go ahead and see what my mass is on here. So again, I need to turn my scale on. Let me direct you that way. And I'm going to center that as best I can. Ooh, would you look at that? 84 grams. So go ahead and record that in the after spot on your chart, and we'll have to see if we can figure out what that means. So 84 grams was our after. So let's go back to our presentation and see if we can't figure out what that means for us. All right, so we had something like this coming out. This is steam that you weren't able to see as clearly on the camera that I was using, but it is there. We heard all of this popping going on. So with each pop, that was vapor being released from the kernel. You could kind of look at it here. Here's a close-up. Look for that water release. We know that water release is what's turned into vapor. So if we could collect all of the steam, the weights before and after microwaving should be the same. So if there was a way to contain all that steam that we saw coming out of there, really we should have ended up with the same weight as what we started with. But since we had some of that escape, our weight ended up being less than what we started. So you also have a space on your worksheet that looks kind of like this, except for it gives you part of the answer in there. So it says, did the microwave popcorn in bag gain mass, lose mass, or remain constant after heating in the microwave? So provide data in your response, and then tell why. Well, part of this has been done for you. So you have something that looks like this on your worksheet, and you will be putting the information on there. So the popcorn weighed how many grams less after using the microwave? So to find that number, you'll have to take that 93 grams that we started with, and you will need to subtract 84 grams from it. And you will write in the number that you find. So how much less was it? It might weigh less because I noticed, what did we notice rising out of the bag at the end? Well, did you say steam? If you did, you are correct. The microwave and bag also had, what did it have on the sides? Well, you might not have seen it, but it did have a little bit of, remember I told you it was kind of moist, so it had some water on the sides. I think the popcorn weighed, and this would be a more or less question. So weighed more after popping, or weighed less after popping, or you might have said weighed the same. So we found out that the popcorn weighed less after popping because the kernel lost water, and water has mass. So you'll want to make sure that those all get filled in on that worksheet before you continue on with the next video. So I'm going to pause this one here, and I'll see you in part 2.